At an extraction site, a jammed dump truck gate is forced to release stuck rocks. Suddenly, a large boulder releases from the raised bed and moves into the open work area below. Forcing a mechanical release with the foot can unlock stored weight in a sudden and unpredictable way. Inside a narrow trench, a backhoe lowers a heavy wooden load when the strap suddenly loses support. Suspended loads depend completely on rigging, balance, and controlled lowering. A strap, hook, or lifting point under pressure can fail suddenly, and gravity controls the movement immediately. In a narrow trench, limited room, reduced visibility, and restricted exit space make the lower path especially unforgiving. The landing area must be cleared before tension is applied, and the load should remain controlled from solid ground until it is fully supported and stable. At a residential patio, ladder work is taking place high against a roof edge. Without warning, the unsecured base slides outward. A ladder is only reliable when angle, friction, and contact are controlled at both ends. Smooth concrete can reduce grip under the feet, especially when climbing pressure or reaching force pushes the base outward. If the lower end slides, the ladder loses its support path, and the roof edge becomes a poor substitute for stable access. Blocking, tying, and checking the setup must happen before weight is placed on the ladder. Secure the highest rungs and firmly block the bottom feet. Maintain the correct balance point. Value solid stability over rushed tasks. A massive transport truck creeps across an old wooden bridge as aging planks carry more weight than the crossing may safely support. Old wooden structures can hide major weaknesses beneath a surface that still looks passable. When a heavy vehicle moves across unsupported or weakened beams, the weight concentrates on sections that may no longer have the strength to carry it. Each tire adds pressure, vibration, and shifting load to the bridge deck. If the beams have moisture damage, age-related wear, or missing support, the structure can lose strength before the vehicle reaches the other side. Stop before crossing, verify posted limits, check structural condition, and choose another route before travel when the bridge rating is missing or doubtful first. On a busy factory floor, activity takes place near a high-speed industrial fan. The strong air intake draws loose hair toward the rotating equipment path. Loose hair, fabric, lanyards, and dangling items can act like a tether near moving equipment. A strong fan does not need direct contact to create risk because suction can draw loose material toward the guard, intake, or moving core. Once loose strands enter the airflow path, the movement can tighten rapidly and reduce the space needed to step away. A safe approach means securing hair completely, removing loose accessories, respecting the intake path, and keeping enough distance from any equipment that draws air, rotates, or pulls material inward. In a quiet storage room, a resting place is positioned beside an old brick wall. Without warning, the wall loses support, allowing heavy masonry to move into the resting area. Weak masonry can remain standing while hiding serious instability inside the wall, joints, and lower support. A resting area beside an old or overloaded partition creates risk because the nearby space may offer little warning when the wall condition changes. When brickwork loses support, the material can release suddenly as one heavy mass into the space beside it. Any rest location inside a worksite must be checked for leaning walls, loose brick, overloaded partitions, moisture damage, and unstable storage nearby. At a demolition site, drilling begins near the bottom of a wall. Heavy concrete sections detach from above and move downward into the work area. Removing material from the lower part of a wall can take support away from everything above it. Once the base is weakened, the upper sections may no longer have a stable path to transfer their weight. Gravity then pulls the unsupported material down through the area directly below. Demolition should follow a planned sequence that controls overhead weight first, keeps the operating position out of the material release path, and preserves a clear exit route before any cutting, drilling, or chipping begins. At a paved yard, movement continues near a tanker truck during a phone call. The surface suddenly gives way along the walking path, exposing hidden water below. Underground water can quietly wash away the soil that supports paved surfaces. From above, the concrete or blocks may still look normal, even when the ground underneath has already become hollow. Walking while distracted can make early warning signs easier to miss, including sinking edges, uneven blocks, soft spots, wet patches, or small surface cracks. When weight reaches the thin, unsupported layer, the surface can open in one quick movement. The safest response is to keep full attention on the walking path, especially around tankers, drains, wet ground, and areas where water may be moving below the surface. Inside a workshop, a grinding tool is applied to a sealed drum. Instantly, the container loses integrity under pressure, releasing a brief flash and strong air movement. Closed drums and barrels can hold invisible residue from old liquids, vapors, or cleaning chemicals. Even when the container looks empty, heat from grinding or welding can transfer through the thin metal wall and activate whatever is trapped inside. As the heat rises, vapor and air expand in a sealed space with nowhere to safely release. The safer approach is to identify the previous contents, clean and ventilate the container, remove caps, test the atmosphere, and only apply heat when the drum is confirmed safe by proper procedure. At a muddy excavation site, work continues beside an idle excavator near a tall concrete wall. Without warning, the massive structure loses support and moves toward the work area. Digging directly beside a freestanding wall can remove the underground support that keeps the structure balanced. Even if the wall looks solid from the surface, the soil at its base may be carrying part of the load. Once that soil is disturbed, the upper sections can lose their stable foundation and move toward the open excavation. Muddy ground adds more uncertainty because moisture weakens soil strength and changes how pressure is carried. Work near walls should begin only after nearby foundations are inspected, support is verified, and bracing is installed where needed. Deep inside a pit, work continues near a towering clay wall. Suddenly, the heavy face releases, allowing dense clay to move into the open workspace. Unstable clay can hold moisture in a way that makes it look firm while still being ready to fail. A vertical soil face is always under pressure from its own weight, and that pressure increases as the wall gets deeper, wetter, or more exposed. Without shoring, sloping, benching, or protective shields, the soil can release suddenly and move into the lower space quickly. The safer method is to control the soil before entering the excavation. Moisture checks, trench protection, safe access routes, and wide marked boundaries are essential whenever steep clay walls are present. Inside an underground mine, a stuck lift cage is forced loose near an open shaft. As the latch releases, the lift loses support and moves along the shaft path. Applying physical force to a jammed lift cage can release stored movement in a way no one can control by hand. When a stuck mechanism breaks free, the weight of the cage, the track, and everything connected to it can shift instantly. Close contact points create direct exposure to the moving equipment path. If the platform loses support, the pull can transfer through anything still connected to it. Mining lifts, cages, and shaft equipment must be secured, locked, and cleared before release attempts. A jam should be handled with external tools, mechanical controls, and full distance from the open shaft. Two security guards struggle to manually close a heavy iron gate at a secure site when the structure suddenly detaches from its hinges and loses guided support. Heavy iron gates rely on hinges, tracks, rollers, anchors, and stops to stay upright during movement. If any of those parts are worn, rusted, loose, or poorly aligned, the gate can shift out of its normal travel path during routine use. Manual pushing adds side pressure to a structure that may already be close to failure. A safe gate system needs regular inspection, proper lubrication, secure anchors, functioning stops, and secondary restraints that prevent the structure from moving downward completely. If one part fails, verify hinge and track security before manually engaging heavy gates. In a textile factory, a suspended bale moves beneath an overhead crane. Within seconds, the hook disconnects, allowing the heavy load to move downward. Suspended materials depend completely on secure latching, correct rigging, and stable movement. When a hook, latch, sling, or connection point fails, the load immediately becomes uncontrolled weight, moving with gravity. Guiding the load by hand from beneath or beside it removes the distance needed for safety. Even a short downward movement can create high force because the object's weight accelerates quickly. Loads should be moved with tag lines, clear hand signals, verified latches, and strict boundaries that keep the lower path empty. No active hoist should require anyone to stand under the suspended item to guide its movement. At a construction site, a backhoe reverses off a trailer bed. The rear tires slip past the platform edge, leaving the heavy machine unstably misaligned. Reversing heavy machinery on a trailer requires slow movement, clear guidance, and exact tire placement. The machine's weight is concentrated through the wheels, so a small drift can place one side outside the supported surface. Once the tire crosses the edge, the machine loses part of its foundation, and the center of gravity begins to shift. Loading and unloading should use spotters, edge markers, proper ramp alignment, low speed, and a clear stop signal before the equipment reaches any unsupported edge. Prioritize slow, controlled movement over rushed backing maneuvers. A massive truck reverses steadily on a paved industrial lot. Without warning, the rear tire sinks through a weak surface, causing the vehicle to lose side stability. Heavy vehicles place enormous pressure onto small contact points where the tires meet the ground. A paved surface can look strong while hiding soft soil, voids, water damage, or weak fill underneath. When one wheel sinks suddenly, the truck's support base changes instantly, and the center of gravity shifts toward the failed side. If the load is raised or uneven, the tipping risk becomes even greater. The safe approach is to inspect travel paths before reversing, test questionable ground, avoid unsupported edges, and confirm that pavement can handle the vehicle weight. At a construction site, a crane lifts a heavy machine. The rigging fails, and the load loses support and moves downward to the ground. A lift is only as safe as the weakest part of the rigging system. Slings, hooks, shackles, anchor points, and connection angles must all match the weight and movement of the load. When any part fails, the machine no longer has controlled support, and gravity takes over immediately. The load does not need much height to create high force when it moves downward. A controlled lift requires verified weight limits, proper rigging selection, balanced connection points, backup planning, and a fully cleared lower path before the crane takes tension. In a private garden, ladder work takes place while high tree branches are being cut. The heavy limb releases unexpectedly, pulling the setup out of balance. Cutting heavy branches from a ladder combines two unstable forces at once: the shifting weight of the branch and the narrow support of the ladder. When the branch releases, it can swing, move downward, or pull in a direction that changes the balance of the cutting position. Tree work should be planned from a stable platform whenever possible, with ropes controlling the limb, a clear cut sequence, and both hands free from the branch's movement path. Inside a warehouse, a loader moves with a raised bucket. The rear tires lift off the ground, causing the heavy load to spill forward as the machine loses balance. Raising heavy material high changes the balance of a loader by moving the center of gravity upward and forward. When the machine travels with the bucket elevated, every bump, stop, slope, or steering change adds more tipping force. Once the rear tires lift, the machine has already lost stable ground contact, and the operator has very little control left. The safest travel position is low, slow, and balanced, with the load close to the ground and the path checked before movement begins. Stability should always come before speed when transporting heavy material. Inside a warehouse, a forklift with its forward view blocked by a massive load enters a shared pedestrian path. Large forklift loads can completely block the operator's forward view, creating blind areas directly in front of the machine. When visibility is reduced, nearby movement may disappear behind the load even when it is close to the travel path. The risk grows when pedestrians and forklifts share the same space without clear lanes, signals, or spotters. Safe movement requires separated walkways, audible warnings, controlled speed, and direct visual contact between operators and anyone nearby. If the load blocks the view, the forklift should travel in a safer orientation or use a guide. At an excavation site, an excavator bucket is used for access into a trench. Instantly, the unstable wall releases, allowing a heavy movement of soil into the open space. Using an excavator bucket for transport places access inside an area not designed for safe entry. Around open trenches, the machine's weight, vibration, and movement can disturb already unstable soil. If the trench wall loses strength, the earth can move quickly and fill the lower space before normal reaction is possible. Excavations require designed access points, tested soil conditions, reinforced trench protection, and strict control of equipment movement near the edge. A descent should depend on a proper access route, not a bucket, especially when the ground itself is unstable. A car cruises down an open highway when a crane boom suddenly loses support from a nearby construction site, entering the vehicle's travel path. Large construction equipment must remain stable even while operating near public roads. Crane booms depend on proper setup, ground support, rigging control, counterweight balance, and structural condition. If any part of that system fails, the boom can move outside the controlled work area and enter nearby traffic space. Drivers passing the site may have very little warning because the movement happens above and beside the road. Work near highways should include strong exclusion boundaries, secured equipment, traffic controls, overhead monitoring, and enough distance to keep public vehicles away from any possible equipment movement path. A flatbed truck makes a sharp turn and unsecured heavy glass sheets slide away from the rack. The shifting weight pushes into the open truck bed area. Heavy glass panels must be secured against both forward movement and side movement before a vehicle starts moving. During a turn, the load wants to keep moving in its original direction, which creates strong side pressure against the rack and restraints. If straps, wedges, or braces are weak or missing, the panels can slide, tilt, or leave the rack. An open truck bed can then become part of the load's movement path. Safe transport requires rated restraints, strong bracing, pre-trip checks, empty truck beds during movement, and wide clearance around the flatbed whenever glass is being moved. In a busy warehouse, a forklift operator inserts forks into a load on a truck bed, causing the cargo to shift. Loading and unloading require full separation between machinery and anyone on the truck bed. When a forklift engages a load, the forks can lift, tilt, drag, or push the cargo in ways that are difficult to predict from close range. A standing position on the vehicle bed may be hidden from the operator's view, especially around stacked materials or large pallets. The safe method is to clear the truck bed first, confirm signals between the operator and ground team, and keep everyone outside the load movement path until the cargo is stable and the forklift has stopped. A massive industrial gate is being slid open when the structure suddenly jumps its track and moves downward without guided support. Large metal gates depend on tracks, wheels, rollers, stops, and guides to keep their movement controlled. When a track is dirty, misaligned, worn, or missing a limiter, the gate can climb out of its normal path during routine operation. Manual pushing often places the operating position close to the structure when the failure begins. Once the gate leaves its guide, its full weight is no longer supported in the intended direction. Safe gate operation requires daily track checks, working stops, roller inspection, secondary restraints, and enough clearance so no one stands in the gate's movement path. In a bustling factory, direct contact is made with an exposed rotating machine part. Seconds later, the equipment cycles again, drawing the contact area into fast motion. Automatic machines can restart or cycle again, even when movement appears paused. Direct contact with rotating parts is risky because the machine is built to move with far more power than a person can control. If the equipment is not isolated, a delayed cycle, sensor command, or automatic program can bring the rotating section back into motion without warning. The safest approach is to stop the machine fully, isolate energy, verify zero movement, and use guarding or tools instead of placing hands on exposed parts. A forklift operator maneuvers near a delivery truck with forks fully extended across the road, creating a hidden obstacle in the path of approaching traffic. Forklifts are not designed to move through shared traffic areas with forks extended. The forks can project far beyond the visible body of the machine, making them difficult for drivers or riders to notice in time. When industrial equipment enters a road or mixed-use lane, the mismatch in size, speed, and visibility creates high risk. The safer method is to retract forks fully, use proper transport equipment, control the crossing with signals, and keep traffic away until the forklift has cleared the lane. Any protruding attachment should be lowered, marked, and kept out of public travel paths. To keep learning from these important workplace safety lessons, make sure you subscribe and turn on notifications. Stay aware, stay safe.